A single teaspoon of this object weighs 14 trillion pounds. Imagine you are standing on the surface. You do not die slowly. You are simply gone, in less time than it takes a photon to cross an atom. Your body doesn't fall. It collapses, folded into itself like wet paper in a furnace. This is not a black hole. This is not science fiction. This is a neutron star. And if you think gravity on Earth is strong, you have no idea what the universe is capable of. Picture a star 12 times the mass of our sun. Now watch it die. It starts with a scream. A star tears itself apart. Not from the outside in. From the core out. This isn't just collapse. It's execution. Fusion stops. The core halts. The outer layers have nowhere to go but down. They crash inward at a quarter of the speed of light. That impact? It doesn't bounce. It shatters. Electrons are driven into protons, crushed into neutrons. The entire core, 1.5 times the mass of our sun, is compressed into a ball 12 miles wide. It's like shrinking Mount Everest into a grain of sand. A single city block of this material would outweigh all the living people on Earth. And in less than a second, the star dies. But the corpse? It's alive, spinning, screaming. It pulses with X-rays like a heartbeat. You can hear it from 10,000 light years away. And this is where it gets wrong. Because now it remembers. It spins faster than your eyelid can blink. One rotation in 1.4 milliseconds. That's 700 times per second. If it were a vinyl record, the edge would be moving at half the speed of light. Centrifugal force should rip it apart, but gravity holds it together. Gravity so strong that if you dropped a phone from waist height, it would hit the surface in a millionth of a second. At 17 million miles per hour, there is no atmosphere, no surface, just a crust of iron nuclei harder than steel, and beneath it, a sea of neutrons so dense they touch. Neutrons overlapping, neutrons melting. It's not matter as we know it. It's like the universe forgot the rules and just squeezed. And the magnetic field? 1 trillion times stronger than Earth's. If one passed through our solar system, every credit card on the planet would erase in an instant. Even from halfway to Mars. The energy stored in that field could, in theory, power human civilization for 10 million years. But here's the thing. You're not getting close. Because if you tried, your atoms wouldn't just break. They'd unravel. Electrons torn from nuclei. Molecules shredded before they touched the surface. You'd be vapor. Then plasma. Then noise. And this is the calm before the storm. The sky would start screaming at you. If a neutron star appeared in the asteroid belt tomorrow, you wouldn't hear it on the news. You'd feel it. First, your phone would die. Then your car. Then the power grid. Not from EMP. From magnetic tremors warping the ionosphere. Satellites would tumble like leaves. The northern lights? They'd flare over the equator, green, red, violet, burning for days. Birds would stop migrating. Bees would vanish. And that's just from the magnetic field. Now imagine it's a pulsar, spinning, sweeping its beam across space like a cosmic lighthouse. Every 0.3 seconds, a pulse of gamma rays. One burst could strip ozone from Earth's atmosphere. 2. Mass extinction. But worst of all, the gravity. It wouldn't yank Earth from orbit. It would tug. Subtle. Relentless. Like a finger hooked in your spine, pulling over centuries. Astronomers would plot the drift. The planets would shift. Jupiter's moons would destabilize. Comets would fall toward the sun, not in thousands of years. In decades. And if it got close? If it passed within 1 million miles? The tidal forces would stretch Earth like taffy. Oceans would rise, not toward the moon, toward the sky. Mountains would vibrate. Crust would split. And then, silence. Because the star's beam would hit us head on. And every neuron in your brain would fire at once. Then nothing. No pain. Just the end of signal. And the universe would keep turning. You are made of dead stars. Every atom of iron in your blood, forged in a supernova. Every calcium in your bones, fused in a dying giant star. But neutron stars? They make the rare stuff. Gold, platinum, uranium. Not in supernovas. In collisions. When two neutron stars spiral together, screaming in gravitational waves. They tear each other apart. In that last second, they vomit out a mountain of gold. Enough to turn a planet yellow. That collision? It happened 4.6 billion years ago, and the debris rained into a cloud of gas. That cloud collapsed, formed a star, formed planets, one with oceans, one with life, one with you. So when you wear a gold ring, you're wearing the corpse of a star's final scream. When you look up, you're looking at a sky written in dead fire. We are not on Earth. We are of dead stars, ashes shaped into thought, dust that remembers light. And right now, somewhere in the dark, two neutron stars are falling toward each other, spinning faster, closer, 1 second from collision, 1 second from forging the next generation of suns, and atoms, and life. This is not the end. This is how the universe remembers.